Welcome back, guys. My name is Dr. Avitek, and in this video I am going to be helping students who are preparing for GCSE, Waec, NECO, or any O-level exam. This very thing is going to help students who are preparing for SAT exams and also iGCSE. So what I'm going to be talking about is mensuration. It's going to mainly deal with the study of shapes, areas, perimeters, and volumes. So for today, we'll be talking about circles only. So today we'll just be discussing circles, and we're going to be starting with area and perimeter of a circle. So this video is going to be a very long video. Not really very long, I'm just exaggerating. But if for any reason you feel exhausted at some point, you can always pause the video, go do something else, and you come back to it. If you're writing Waec this year, you do not want to miss this very video. Don't skip any part. Listen to all the explanations, and remember to hit the subscribe button, like this video, and share it across to everyone in your contact list. So I want to get started with kind of talking about the parts of a circle. So I want to start by that. I want to start by talking about the parts of a circle. So this one majorly focuses on the lines in a circle, the lines that we have inside a circle. Then this one discusses about the portions, the portions in a circle. Yeah, a portion. I do call it region in a circle. So first of all, what is a circle? We all know what a circle is. We've been singing songs, make a big circle like your mother's cooking pot. So we've been, making circles for a very long time. So it's a very easy shape to know that, oh, this is a circle. So it's a round shape. It's a round shape. And this very shape must have a center. So in this case, this is the center, this is the center. Let me put an angle here. So that's the center. We know what the center is. Okay, good. The first common part that everybody knows is the radius of that very circle. What is radius? Radius is a line from the center to the circumference. So what is circumference? Circumference is this round thing. Take note, it's not only circles that have circumference. Any shape can have circumference. What is circumference? Circumference is basically the sum of the external length, or you could say the length of the external path making up the shape. So if you have a circle, if you sum this up, like if you take the distance around that very circle, you have found the perimeter of that circle or the circumference of that circle. So perimeter and circumference, they mean the same thing. So they mean the same thing. So when you draw a line from the what's it called? From the center to the circumference is called radius. So that's what radius is. Radius could be at any point. So radius could be maybe from here to here. As long as it's from the center to the circumference, it's the radius. Now what is diameter? Diameter is double of a radius. So since it's the double of a radius, it divides the circle into two equal parts. It divides the circle into two equal parts. Now what is a chord? A chord is also, okay, a diameter is a chord. Let me put it that way. A diameter is a chord also. Because what does a chord do? A chord is a line that divides the circle into two parts, but they're not equal. They are not equal. But diameter would divide it into two equal parts. So spot the difference. Chord would also divide into two parts. But diameter, these two parts are going to be equal, forming semicircles. A semicircle is half a circle. Alright, what is a tangent? A tangent is a line touching the circumference of the circle at one point. So it's going to have a point where it touches, that very circumference. It's an external line. It does not cut through the circle. It does not. If it cuts through the circle, it becomes a second line. It becomes a secant. So, but in this case, it's not going to cut it. So it's just going to touch one point. It's just like, if you take a ball, put the ball on top of a table, that table is a tangent. So visualize it. The table becomes a line, then the ball is on top, resting on top. So that's what a tangent is. The table is a tangent. Now what is an arc? An arc is basically, you see, the circumference, which is the round thing, you see the length of that round thing making up the circle. If you take just one portion of it, that is if you cut it, you take just one portion of it, is an arc. So an arc is a portion of the circumference. An arc is a portion of the circumference, just a portion. So So it's the circumference, but you're just picking a tiny part of it. So that's what an arc is. So let's come to regions. I like calling it regions. So the one I like most is a sector. So for those of you that have eaten a pizza before, so when you buy pizza, you'll notice that they've been cut. So the moment you buy them, they actually cut it into parts. So each part, when you pick up each slice, it looks like a sector. It kind of looks like this. I don't want to draw anything here, but it kind of looks like this. Though this side is kind of, kind of like not that straight, but this is what it looks like. And of course, people take it from this part and they start eating from here. So that's what the sector is. But for a circle, we'd like to say that a sector is a region bounded by two radii. So you must have the radius, two of them, this, and then an arc. So any region bounded by an arc and then two radii, it's not radius, it's radii. So a plural of radius is radii. So that very formation would form a sector. Now, what is a segment? Remember I told you that a chord will divide a circle into two equal parts. So a chord is a line. But the region that will be formed between that very line and the arc, remember an arc is a portion of the circumference, is a portion. So that region that is formed is a segment. Is that okay? All right, so with this, let's move to this very part. So what did I tell you? Circumference. I don't know if you can see this. Oh, I doubt if you can see this tiny rubber band. I doubt if you can see this. But if you can see this, so this rubber band, this very guy, the surrounding part is the circumference. If I cut it for some reason, I really hope I can. Oh, so this is it. You see, it kind of forms a line, right? Good. This explains what I've just done right now. We are going to use it very soon to solve some problems. So you see that, like this question 5 says that we flatten. I'm going to come to this very soon. We flatten. So you notice that you have something like this. It's a circle. But of course, if that circle turns once, if it goes once, it kind of forms like a line. That very thing you formed is the circumference. So take notes. We're going to discuss, I think I'm going to keep this very close to me. All right, so let's get started. The first question says, the radius of a circle is 14 centimeters. But to find the area and find the circumference. Okay, so let's get started. So first one, area is pi r squared. That's area of a circle. It's pi r squared. So in this case, we're going to be using pi as 22 over 7. Radius squared, so that's 14. We're going to say 14 cm times 14 cm. That's what we're going to do. 14 cm times 14 cm. I don't want to waste time in this video, so I'm going to be using a calculator for that. So we have 14 times 14 times 22. Then I'm going to divide by 7. So that will give me 616. So this will be 616 centimeters squared. So this is the area of the circle. How about circumference? Circumference is 2 pi radius. Circumference is 2 pi radius. So this will be 2 times 22 over 7 times 14 centimeter. And of course, I think this should be around 88 if I'm not mistaken. 2 times 22 times 2. Yeah, 88. So this is 88 centimeters. So this is it. Another explanation, another thing I want to explain about this very thing is area. What area talks about is the space on a thin sheet of material. If you have a circle, let's say, okay, if we should draw a circle on the ground, let's say that one human being is 1 meter square. Area is asking us how many humans can be on top. How many humans can stand on top. So area is basically a surface thing. It's talking about how much can we place on the surface of a very thin sheet of item. So that very thin sheet, that very thing that will be on top, how much space does it have? That very space, we're talking about the surface area. The area of just one surface, just the surface. We don't want to go in it. Of course, a circle is 2D, so we don't want to go inside. It's just a surface. So that's what area is. So I've defined two things for you. Area talks about space, how much space a particular surface would have to contain 1 meter square of something, like multiples of it. Then circumference is the length of the outline. So this very circle has an outline. So the length of that very outline forms a line, basically. You see, back then, mathematicians, to find the circumference, they would cut it or use a rope. Those of you that did geography and you did map reading, you do notice that they could tell you to use a thread to kind of measure a distance on the map. Then you use that thread and put it on a ruler. So there used to be some times where people would, instead of measuring what a circle is, before we got the formula, they said that we could go around this very shape with a rope. When we're done, we then place that rope on a ruler. So that's what circumference is. Circumference is just the length of the outline. All right, what I've just actually defined is how we found pi, the derivation of pi, how we derive pi. But let's move on, please. Let's move on. Okay, question 2. The area of a circle is 154 centimeters squared. Find the radius. So this is question number 2. Okay, we know that area is pi r squared. So that's what area is. So in this case, area is 154. So this is 154 centimeters squared. Then our pi is 22/7. And then r squared. Okay. We're Nigerian, so we basically solve like this. So we could cross multiply. So we do 154 times 7. So that will be 154 centimeters squared times 7 equal 22 r squared, because we only times him by 7. So the 22 r squared will remain, and this 7 will times this very guy. And of course, I need to use a calculator for this. Okay. 154 times 7. So that's 1078 equal 22 r squared. So the next thing we're going to do is to divide by 22. We're going to divide by 22. So this will give 49 centimeters squared equal r squared. Now to get the value of r, we're going to take the square root of this. So the square root of 49 centimeters squared will give us the radius. And in this case, square root of 49 is 7. Square root of centimeter squared is centimeter. So this means the radius is equal 7 centimeters. That's what the radius is. Okay, let's move on. That's number 3. The diameter of a bicycle wheel is 42 centimeters. If the wheel makes 16 complete revolutions, what will be the total distance covered by the wheel? Okay, so you have a bicycle. You want to kind of ride somewhere. Maybe you want to go to school or somewhere. So when you're driving, should I say drive, or you are riding? We ride bicycles. So when you ride the bicycle, if your wheel, the bicycle wheel, if it turns once, you've actually turned one circumference. One revolution is like one movement around the outline of the shape. Around the outline of the shape. So that's what one revolution is. So we have to find the circumference of that very wheel. What is the length of that outline? Because if I start at a point and I roll that very full circumference, I formed one revolution. So circumference is 2 pi radius. But of course, there's a formula for with diameter. There's a formula that has diameter. So we could say pi d. This is also another way. But remember that diameter is 2 times radius. 2 times radius. So this means that radius is diameter over 2. So if you wish to find the radius, your choice. But circumference is equal to what? Pi d. So this will be 22/7 times the diameter is 42 centimeters. All right, this here is 1. This into this is 6. Okay. So if we double that, I think we should be getting around 132. But I'm going to check this with a calculator. I want to try my best and make sure that everything goes well today. Okay, so we have 22 times 6. 132. So this is the circumference. And in fact, this is not just circumference, this is one revolution. One revolution. Now, the wheel actually makes 16 revolutions. So it means we're looking for 16 revolutions. So this will become 16 times. If this is the value of one revolution, that means 16 will become 16 times 132 centimeter. So 16 times this will give us 2,112 centimeter. So that's the value of 16 revolution. So take note of this, please. Take note of this. All right. Question number 4. Question 4. How many times, correct to the nearest whole number, will a man go around a circular track of diameter 100 meters to cover a distance of 1,000 meters? Most of us looking at this, we just do 1,000 over this, so that's 10. No, you don't do that. So here's the thing. Let's say there's a competition and the track which they're going to be running, that very track is having a diameter of 100 meters. Take note, when you go around that very diameter, that very circular track, you've covered one revolution, which is one circumference. When you go around something, basically, it's a revolution. When things turn around, they've revolved. Should I say revoluted? But that word, I don't think it exists. So when you go around a particular shape, you've actually gone one circumference. So first things, let's find the circumference of that very track. If somebody goes around that very track, what would the person get? So we know that circumference is pi d, since we're given diameter. So this will be 22 over 7 times our diameter is 100 meters. Okay, for this one, I think we're going to be doing a lot of approximation. Okay, so this will be 314.29 centimeter. So that's the circumference. That's the circumference. But then the man wants to cover a distance of 1,000 meters. That's what the man wants to cover. So here's the thing. If the man goes round once, he's going to cover this distance. Wait, so this is in meters, not centimeters. So if the man goes round once, he's going to cover this distance. If he goes round twice, he will cover double of it. So that's about 628.57. He will cover 2 times of it. If he goes again, they're asking us how many times does he have to go to complete 1,000 meters. Now that's very simple. The number of times he should go will become, we need him to cover 1,000 meters, and one of them, one turning, if he turns just once, is going to get 314.29. So we're basically just doing 1,000 divided by this number. All right, so this will give us about 3.18. 18 times. Okay, now the equation is correct to the nearest whole number. So this will be 3. 3 times. So he has to go 3 whole times to get that very value. Okay, so this is what we have. That's the answer to that very question. Let's move on to question number 5. A road roller, this question is going to be one of the craziest one. A road roller has diameter of 1.5 meters and a width of 225 meters. How many meters square of road will it flatten if it turns 20 times? I believe you've seen those people that used to do road, the civil engineers that construct roads. So they kind of push, it's more like, it's not a wheelbarrow though, but there's something they push on the ground to flatten the coal tar. It's not coal tar, the coal tar that they pour on the floor. So to flatten it, if it's not to flatten, maybe when bitumen is being added, to make sure that everything is evenly distributed. Either there is the one they control by hand, and then there's the one that is very big, that is like a machine. So you see someone controlling that very one, moving with it. So we have the machine, we have the hand. So what I'm basically saying is, that very road roller, hopefully I can put an image here so you can understand this query equation. So that very road roller, and I know I'm going to draw a weird shape. God, I'm going to draw a weird shape. So let me draw something like this. I know it's going to be weird. Okay, so somebody is pushing this very thing. So this is the roller. This is the roller. So this is the roller. Oh, I would have brought out a paint. I have a roller inside. I would have brought it out. It's a perfect explanation for this, but I don't have the time to bring it out. So this very roller is flattening a surface. The first thing you want to know is, for this tiny part, let's say we cut out these remaining ones. We want to know what this full guy would be, this circumference. Look, let me join this rubber band back. So I join this rubber band back to its original form. It's going to form a circle. But this is a very simple circle. This very circle is the smallest possible, it's a very tiny thing. It's not having a width, unlike this one that has a width. So for this one, I don't want to say anything about the width. So this one has no width. It's very, very thin. The width is almost insignificant. So in this case, I want to know what the circumference is. Because if I know what the circumference is, that means if I should flatten it, I know how much length is going to cover. I know how much length is going to cover if I should flatten this very circle. So the first thing I want to get is the circumference is pi d. So that will be, but I have to use 3.142. So since it was specified, 3.142 times our diameter is 1.5 meters. So this is what we have. So this is our circumference. Gosh, I need to use a calculator for that. K 3.142 times 1.5. Okay, so this is 4.713 meters. Now that's the circumference. That's the circumference of just one very tiny bit. But then, we're not covering, this is a road. We're not covering length here. We're covering area because the shape has a width. The shape has a width. So how much area is that roller going to cover? That roller will cover, let me say, area of roller. That area is going to cover up an area of the circumference times the width. Now, why is it that way? Remember I told you that you've been able to find out just one length if it's flattened by just one circumference. But then the shape is not this tiny. The circle is not this tiny. The circle is very thick. It has a width of 225. That means to get the area that is going to cover up, we're going to do that circumference, because the circumference will keep on flattening per unit meter. It's going to keep on flattening. So to get this, we're going to say 4.713 times 225 meters. So this is what we have. Oh gosh. Okay. So times 225. Gosh. So this will give 1,060.425 meters squared. It would then be meters squared. Oh, this one has meters. I should have put that. So this one is meter times meter, meter squared. So this is now the area the roller will cover. This is the area that the roller will cover if it turns once. So if it turns 20 times, it will then be 20 times 1060.425 meters squared. So this will be 21208.5 meters squared. All right. So you can see how this problem can be solved. So let's solve number 6. Although there's no number 6 here, but let me just add it. Number 5, number 6. Find the circumference of a circle with radius 9 cm. Leave your answer in terms of pi. Okay, so I just remember this very question. For students who are taking GCSE, and even Nigerian students too, you would see equations that are left in terms of pi. So I want to solve a question on that. So I have to find circumference. So circumference is 2 pi radius. Now the radius has been given to us as 9. The radius is 9. So this will be 2 times, you know pi is 22/7, right? But I will not write it. Why won't I write it? Because it says leave our answer in terms of pi. So it means pi will still be here. Pi will still be here. Then times what's our radius? 9 centimeters. 2 times 9 is 18. So this will be 18 pi centimeter. That's the answer. This is what it means to leave your answer in terms of pi. So you wouldn't substitute pi. Don't remove it. Leave it. That's what it means by leave your answer in terms of what? Pi. So let's move on to length of a chord. Yeah, so let's start with chord or arc. Okay, anyone. So let's move on to length of, let me see. Oh, we're moving up to length of an arc. So these are all the equations I have, their meaning. Yeah, but we're going to do all of them. So length of an arc is the next one. Okay, so this next section, we're going to be talking about the length of an arc. So like I told you, this very video is going to be all encompassing about circles. And when I'm done with this series, so this very video will be on circles. The next one will be on squares. Next one, rectangle, and so on. I'm going to be done with all the shapes. I kind of think I should even put rectangle and square together. Rectangle, square. Yeah, I'll put rectangle and squares together so that we see how we progress. We're going to finish up all of the shapes and then we'll move on to circle theorems. Circle theorems, one video, I'll trash everything. All right. So we have the first one here is this. Remember I told you at the beginning of this video that, where did I keep that rubber band? Remember I told you at the beginning of this video that an arc is a portion of the circumference. An arc is a portion of the circumference. The circumference of a circle is 2 pi radius or pi d. That's the circumference. What is a portion? A portion is like a fraction because an arc is not the full thing. If it was to be the full outline, the arc would be called the circumference. But the arc is not the full outline, it's just a part of the outline. So it's a fraction of the outline. Now, how do we get this very fraction? This very fraction, because a circle is going to be 360 degrees, this very fraction is always going to be theta over 360 degrees. Remember, the 360 degrees is from the angle at a point, the angle at the center. So this angle, when you sum up everything around this very point, you get 360. So the angle that you're always going to be considering when finding what portion is always going to be theta. So the fraction is theta over 360. So the length of an arc is theta over 360 degrees times 2 pi radius. That is it. So it's going to be the portion times, I told you that it was supposed to be a full one, but of course it's just a portion. So this, you need to multiply by this very fraction so you get a lesser value. All right, so the first one is question 7. An arc of a circle subtends an angle of 30 degrees at the circumference of a circle of radius 21 cm. Find the length of the arc. To start with, ladies and gentlemen, please take note that the angle must be the one at the center. This very theta must be the one at the center. It's a must. But this angle was where? It was at the circumference. So what would I do? I need to remember that the angle at the center is always 2 times the angle at the circumference. Yeah, sometimes it happens. Yeah, there are times where this would happen. So just pay attention. The angle must be at the center. If it's at the circumference, you need to double it. So this will be 2 times 30 degrees. So that's 60 degrees. So this is what I'm going to be using. This is what I'm going to be using. So the length of the arc is going to be theta over 360 degrees times 2 pi radius. So that will be 60 degrees over 360 times 2 times 22 over 7 times 21 centimeters. I don't want to be cancelling out. I don't have that strength. But I know this is 1/6. Okay, sorry. Let's just proceed. So we have, that's 1/6. So 2 times 22 times 21 equal to this, okay? Divided by 7 divided by 6. Oh, 22. So this will give 22 centimeters. So that's the length of the arc. That is the length of the arc. So all I had to do, you can actually cancel out too. It's just that I don't want to take up time. So you can multiply everything at the top, multiply everything at the bottom, then you divide. So it's still going to be the same thing. Question 8. Calculate the length of an arc of diameter 14 cm, which subtends an angle of 90 degrees at the center. When I see this question, the first that comes to my mind is, what portion of the circle is the arc taking? The arc is actually taking a quarter of it. It's taking 1/4. So this, how did I know it's 1/4? This is 90, Abi. So what is 90 divided by 360? That's 1/4. So what portion is it taking? The portion is going to be a quarter of it. But you might not really need that. But let's continue. So length of an arc is theta over 360 degrees times 2 pi radius. So this will be 90 degrees over 360 degrees times 2 pi. The radius is 14 cm. Now, what do you notice here? I did something. I left it in terms of pi. So the answer for this question, I want it to be in terms of pi. I don't want to touch it. It should be in terms of pi. Okay. So I already know this is a quarter. This is 1 here. This will be 4. So this is 7 pi centimeter. Yep. Yep. So that will give you 7 pi centimeter. So that is the length of the arc. That's the length of I want the answer to be this. Oh my God. I saw an error just now. Oh gosh. There's a mistake. What's the mistake? This was diameter. So I went to use radius. So I forgot to divide it by 2. So sorry about that. So I'm supposed to divide this by 2. So the answer is 7/2 pi centimeters. Oh, my bad. So that's, if you wish to use radius, always remember that it's always diameter over 2. So this very 14 you see, is going to become 14/2. So that is 7. So once you do this, you have found the radius. Or you can just use pi d. If you use pi d, your answer will still be the same. Okay, so that was just the error. Thank God I was able to spot that. Number 9. An arc of a circle of length 22 cm subtends an angle of 3x at the center of the circle. Find the value of x if the diameter of the circle is 14 centimeters. Okay, of course, there are different ways to solve this problem. Yeah, the thing is, the question is asking you to find the value of x. Length of an arc is theta over 360 degrees times pi d. I just put in pi d because this has what? Diameter. This has diameter. All right. So the length of the arc is what? 22. So 22 is equal, what is theta? The angle is what? 3x over 360 times pi d. So in this case, this will be 22/7 times diameter is what? 14. It's a very nice one. Very, very nice one. In this case, I'm going to cancel out. So 7 here is 1, 7 here is 2. Nice. 3 here is 1, and into 360 is 120. That's beautiful. 2 here is 1, 2 into this is 60. That's so nice. Whew. I like this. 22 and 22 can cancel out. They can both cancel out. But I know that will be weird for you. That might be weird to you, but I'm just gonna leave it like this. 22 will cancel out 22. It will. The thing is this. You know, if I should leave it 22 here, that is I have 22x. You now have to say divide both sides by 22 at the end of the day. So if I should say divide both sides by 22 at the end of the day, the answer is still going to be the 22 will cancel out 22. So I don't think there's a need for me to stress myself. So this is a 1. What will be left at the top here is x all over what? 60. What does this basically tell me? This tells me that s is equal to what? 60 degrees. Because 60 over 60 is equal to what? 1. Or you could say cross multiply and your x will become what? 60. Yeah, so that's what the answer will be. Number 10. And of course, remember, you can also decide to multiply everything at the top, multiply everything at the bottom, cross multiply, then your answer will still be the same. Okay, number 10 says an arc of a circle, radius 14 cm, is 18.33 cm long. Calculate correct to the nearest degree the angle which the arc subtends at the center of the circle. So again, length of an arc is theta over 360 degrees times, was that radius? Oh yeah, 2 pi r. So the length of the arc is 18.33. So theta is not known, so that will be theta over 360 degrees times 2 times 22 over 7. The radius is 14. Now, sometimes there are some persons that will go and make the, since we are looking for angle, so persons might go and make the angle subject of the formula. So it's a thing of choice. Some people might go and do that. So it's still nice if you do so. It's still nice. 7 here is 1. 7 into this is 2. 2 here is 1 into 360 is 180. 2 here is 1 into 180 is 90. 2 here will give us 11 into 90 is 45. So this will become 18.33 equal theta times 11. That will give us 11 theta over 45. Now we can cross multiply. So 1 times 11 theta is 11 theta. Then we have 45 times 18.33. So this is what we have. So this will then become 11 theta equal, we have to do 45 times 18.33. That's weird. So that's 824.85. Okay, so to get theta, divide both sides by 11. That will be 824.85 divided by 11. So when you divide by 11, this will give 74.98. Now, to the nearest degree, this will be 75 degrees. That's what we have. This will be 75 degrees. And that will be the answer to this very problem. And with this, we're done with area of, what's it called? Of an arc. Yes, we're done with this. But I want to chip in something else. I want to add one question to this. Question 11. So this question is not about arc. Okay, no, I'm just going to do it later. So let's move on to length of a chord. That's the next thing we're going to be discussing, length of a chord. Okay, so for this other part, we'll be discussing the length of a chord. Now, I could just write the formula or derive while we have the formula. So let me do a little. Nah, I'm not deriving anything. So let's just know that the length of a chord is 2r sine theta over 2. That's the formula for the length of a chord. So you have to be very careful with this. These two cannot cancel these two. No trying. Don't give it. They can't cancel out. Okay, so this is the formula for length of an arc. But we could find this using basic trigonometry. So I don't want to do that. All right. So the first question says, find the length of a chord which subtends an angle of 90 degrees at the center of a circle of radius 8 centimeters. So first of all, so for this very question 11, the length of that chord will be 2 times the radius is 8. So that's 8 cm times sine. The angle is 90. So that's 90 degrees over 2. So this will be 2 times this will give us 16 centimeters times sine 45 degrees, because 90 over 2 is 45. So this is 16 centimeters times sine 45 is root 2 over 2 from special angles. So 2 here is 1, 2 into 16 is 8. So our answer will become 8 times root 2. So that's 8 root 2 centimeters. Take note, for writing Waec, I believe sometimes Waec will leave the answer as a decimal. If they do, press your calculator. Press sine 45, then times 16. You will get the same answer. So it's either in the decimal form or in this form. Anyone is correct. Anyone is correct. But it depends on what the option says. So go and learn special angles. Go and learn it. So you'll still learn it on this channel. Videos are going to be coming out back to back. Hopefully back to back. All right, question 12. A chord of a circle of radius 3 cm subtends an angle of 60 degrees on the circumference of the circle. Find the length of the chord. Remember I told you, if you hear circumference, go and find the one that's at the center, because we always use the one at the center. So the one at the center is 2 times circumference. So this will be 2 times circumference here. The angle we have is 60. So this will be 120 degrees. So that's the angle at the center. So now length of the chord will become 2 arrow sine theta over 2. So this will be 2 times our radius. Where's that guy? Our radius is root 3 times sine. The angle is 120 degrees, then over 2. So this is 2 root 3 times sine. 120 over 3 is 60 degrees. So this is 2 root 3. Sine 60 is root 3 over 2. Sine 60 is root 3 over 2. So 2 we cancel out 2. Root 3 times root 3 is 3. So this will be 3 centimeters. So that will be the length of the chord. That's what we have. That's the length of the chord. That was an easy one. Question 13. Find the angle subtended at the center of a circle by a chord which is equal in length to the radius of the circle. I gave this question to some SS3 students one time, and they were like, but no measurement was given. How can we find a shape like this? How can we understand the question like this? It's a very simple one. So I believe most of the times, the derivation, students do not go through the derivation process. So they tend to not really understand when a equation does not have numbers. So because of that, I'm going to draw something here. So let's say this is a circle. This is a circle, then this is a chord. I want to derive the formula. So this is the center. So we'll have something like this. So this is the angle here, theta. Please take note, I want to derive the formula. So the line AB, this line AB is the chord. Remember I told you a chord is just a line touching the 2 points on a circle, but it does not divide the circle into 2 equal parts. So this is the chord. Let me even use a red marker to denote it. So a red marker to show that this is, oh gosh, I hate, okay, didn't touch me. I hate this marker. Okay. So for this, the red line is our chord. So let's proceed. Where's this guy? So this angle here is theta. I can't really make do with this because I know this is radius and this is also radius. Can I bisect this? So the line coming through here will bisect that angle and also bisect this line. What I mean is, this line here if this is x and this is x for some reason, if this is x and this is x, this line here bisected it, that's why. And if the angle here was theta, because it's to bisect means divide into two equal parts. So this means that one part now is now theta over 2. Then this other part, theta over 2. But we're concerned with just one section. So let me draw just that section out. We're concerned with just one section. So for this one, the angle here is theta over 2. This is x, this is arrow. This definitely has to be 90 because it's a perpendicular bisector. So we're looking for what? We're looking for x. Do you agree that s is the opposite? S is opposite to this angle. So this is the opposite. Then this is the hypotenuse. You can see that, right? Good. So this is what we have. Now, opposite and hypotenuse, from SOHCAHTOA, only sine is going to work. So sine of the angle is always opposite over hypotenuse. So this is sine. What is the angle? The angle is actually theta over 2. What is our opposite? The opposite to that angle is x. What is our hypotenuse? It's the radius. Now, since we are dividing by the radius, we need to cross multiply, or we can say multiply both sides by arrow. So arrow sine theta over 2 is equal arrow times s over arrow. So arrow, we cancel out arrow. So what does this tell us? This tells us that s is equal arrow sine theta over 2. But is this the length of the chord? No. Remember that we divided the chord into two equal parts, abi? So to get the full length of the chord, if we need the full length, we need to double this thing. Because what we found is just x, but our chord was divided into s and s. So s plus s is 2s. So to get the length of the chord, we need to double this. So that's 2 arrow sine theta over 2. So you can see I've derived the formula. Now, why was this derivation very important? Let me redraw this shape again. I'm going to draw this again. This is a chord. This is the center. Aha. Now, if you look at this properly, if you look at this, they're saying that the, what is it called? The length of the chord is equal to that of the radius. So this radius, we already know that this and this are the same, abi? We know. Now the question is also saying that this one is also the same. Are you thinking what I'm thinking? This is the same. These two are normally the same because their radius is normally the same. And I'm saying that this chord is also the same. So what do we have? An equilateral triangle. So the angle here is what? 60. Because in an equilateral triangle, all the angles are also equal. So this tells me that the angle at the center is actually 60. I don't need to kill myself. That's just it. The angle at the center is equal to 60. That's the answer. So if I were to be in an exam, I would be able to solve that question very fast. But how would we solve the equation if we don't know this? If we don't know this, see what I will do. Length of a chord is 2 arrow sine theta over 2. That's good. This is the formula for length of a chord. The length of the chord and the radius are the same. So I can remove this length and put arrow. Because I know that the length is still arrow. They're the same. So equal to arrow sine theta over 2. Now, can I divide both sides by 2 arrow? Yes, I can do so. So this will be arrow over 2 arrow equal to arrow sine theta over 2 over 2 arrow. So this will cancel this out. If arrow cancels out arrow, there will be 1 at the top. So this is 1 over 2 equals sine theta over 2. Now, what do we do next? This is a half. This is a half. Now, sine of what angle we got will give us a half. You can use a calculator for this. You can say sine inverse of 1 over 2 will give us theta over 2. Because to get this very thing, you need to understand that this angle here will give you 30. So check it out. Use a calculator. Sine of what angle will give us 1 over 2. To get that, all you need to do is to take the sine inverse. So sine inverse of this from a calculator is 30 degrees equals theta over 2. Now to get theta, we need to just times both sides by 2, or you can say cross multiply. So theta is equal to 2 times 30. So that will become 60 degrees. So that's what theta. So you can see that it's still 60 at the end of the day. So let's move on to the next. we're going to go into perimeter of a sector. All right, so for this section, we're going to be solving perimeter of sectors. Now, I've earlier explained what a sector is and how they look like. And let me just give a brief explanation of it again. So, a sector kind of looks like, if you see, you have a full circle. A sector is something like this. That's what a sector is. Now, you know this is the radius. This is the radius. This portion is an arc. This portion is an arc. So let me wipe this side. Yep. So you can see this is what we have. So this is what a sector is. And now from this illustration, you can see that the perimeter of a sector, so I'm going to put solution, perimeter of a sector is radius plus radius, so radius plus radius, plus the length of that very arc. Because remember I told you that perimeter is the sum of the length of the outline, or perimeter is the outline itself. What is the length of the outline? So we need to add up every single side here. So arrow plus arrow is 2 arrow. Then the length of an arc is theta over 360 degrees times 2 pi radius. So this is the formula for the perimeter of a sector. So with this, let's start with the first one. So a sector of a circle with radius 6 cm subtends an angle of 60 degrees at the center. What is its perimeter in terms of pi? Okay, so for that first one, this will be 2 arrows, so that's 2 times 6 cm, then plus theta is 60 degrees divided by 360 degrees times 2 pi times 6 cm. Remember they said in terms of pi, so our answer will be in terms of what? In terms of pi. Now, 2 times 6 will give us 12, so this is 12 cm plus, you can tell that 60 into 60 is 1 and into 360 is 6. Now, this 6 can cancel out this 6. So what's remaining here will be 2 pi centimeter. Now, you can tell that the answer to this question will become 12 plus 2 pi cm. Because the cm is common, so this will be the answer. This will be the answer. You can also write it as 2 pi plus 12 cm. You can even write it as 2 brackets pi plus 6 cm. They are all the same. So this very one is because 2 is common between these two guys. So 2 is common. Since 2 is common, you can bring it out. 2 pi over 2 is pi. 12 over 2 is 6. So you can also leave the answer in any of these ways. This is what we have for question 14. Question 15. Remember to hit the subscribe button, like this video, and share it across to all of your friends. So a chord subtends an angle of 120 degrees at the center of a circle of radius 3.5 cm. Calculate the perimeter of the minor sector containing the chord. Okay, this question is also about perimeter of sectors. And of course, a chord could actually form a sector. Like you could use a chord, the language. Let me explain. So, if I should connect a line like this, this becomes a chord. This line here becomes a chord. You know it was a full circle, so this is the chord. That's saying find the perimeter of this very sector. So you are not using chord here. I think most places will be confused, but please, it's not the chord we're using. Now, another thing that might be confusing is what this minor sector is. Remember I explained that every single thing is a portion of the full circle. So a sector, for example, is a portion of the full circle. So the angle that it subtends, we could get what portion it takes. So the theta over 360 is what tells us what portion, what fraction it takes, the amount of fraction it takes of the circle. Now, if we're talking about the minor sector, a full circle is 360 degrees. That's what a full circle is. So half of 360 is 180. So this means if any angle at the middle is more than 180, is seen as major. It is seen as what? Major. So what this tells us is that we can either have a major segment or a minor segment, a major sector or a minor sector, a major arc or a minor arc, depending on what the angle is. So if the angle is less than 180, is minor. If the angle is more than 180, is what? Major. So pay attention to that. All right, so with this, we're going to solve question 15. So the perimeter of a sector is 2r plus theta over 360 degrees times 2 pi radius. So this will be 2 times, the radius is 3.5, so this will be 3.5 plus the angle subtended is 120 divided by 360, then times 2 times 22 over 7 times 3.5 cm. Like I said, in this case, we're going to be using the 120. Assuming the equation says major sector, we need to then do 360 minus 120. Hopefully, let me see if equation is going on. Anyways, we'll see about that. If it does not, if there's no question here, I'm going to explain using one question how to find the angle subtended by anything that is major. But I've said it before that when the angle is more than 180, that thing is major. When it's less than 180, is minor. So since we need the minor, we're going to be using the 120 degrees. Well, 2 times 3.5 is 7. 120 here is 1. And into 360 is 3. 2 times 3.5 is 7. So together, they will join hands to cancel at 7. So we're going to have 22 over 3 remaining. 22 over 3. So this will be 7 plus 22 over 3 is 7 whole number, 1 over 3. So 7 plus 7 is 14 whole number, 1 over 3 cm. So that will become the perimeter of that very sector. For this part, you can actually use a calculator. You know, multiply everything at the top, multiply everything at the bottom, then you divide. You're still going to be getting this. So that's the answer for that one. Let's move on to question 16. So question 16, a sector of a circle which subtends 172 degrees at the center of the circle has a perimeter of 600 centimeters. Calculate to the nearest cm the radius of the circle. I kind of like this question. So we know perimeter is 2r plus theta over 360 degrees times 2 pi radius. Now the perimeter has been given to us as 600. So that's 600 equal 2 radius plus theta is 172 degrees all over 360 degrees times 2 times 22 over 7 times the radius. Hold on, I need a calculator at this. So this becomes 600 equal 2 radius plus. Now what I'm going to do is I'm going to multiply everything at the top. So 172 times 2 times 22. Okay. Divided by 360 divided by 7. Gosh, that's a big number. Okay. So this will give us around 3r. To give us around 3. This is 3.003. So it's almost 3. So that's what that will give to us. So this is 600 equal 2r plus 3r is 5r. So to get the value of r, we're going to divide both sides by 5. So 600 divided by 5, that's 120 equal to radius. So r is equal 120 centimeter. That's big. That's big. Okay, so that's what we have for question number 16. Yeah, question number 16. Question 17. The perimeter of a sector of a circle of radius 4 cm is pi plus 8 centimeter. Calculate the angle of the sector. All right, so perimeter is 2r plus theta over 360 degrees times 2 pi radius. Now the perimeter is pi plus 8 equal 2 times 8, 2 times 4 because the radius is 4, plus theta over 360 degrees times 2 pi times the radius is 4. Now why did I leave this pi like this? You know that the perimeter was left in terms of pi. Also leave this side in terms of pi too, so that you can check if they will cancel out at the end of the day. So leave here as pi also, because the other side is also having pi. So this will be pi plus 8 equal 4 times 2 is 8 plus 2 times 4 will give us 8. So times pi times theta, that would be 8 pi theta over 360 degrees. Now I can take this 8 to this other side. So this will then become pi plus 8. If this 8 goes right, to become minus 8 equal to what will be left is this one. So that's 8 pi theta divided by 360 degrees. Now this is pi. This will be pi equal to 8 pi theta over 360 degrees. I think this can cancel out. It should. 360 and 8. Is that 45 or hold on, let me see. 360 divided by 8. 45, yeah. So 8 here is 1 and into 360 is 45 degrees. So this will then become pi equal pi theta divided by 45. Now I can put over 1 here and cross multiply. So this will times this will times this. 1 times pi theta is pi theta. Then pi times 45 is 45 pi. Now pi can cancel out pi. That means theta is equal to 45 degrees. So that will be the angle. That will be the angle. All right, let's move on to the next one. Question 18. Question 18 says a circle is divided into 2 sectors in the ratio 3 is to 7. If the radius of the circle is 7 cm, calculate the length of the minor arc of the circle. Now, this question actually, this very question, is supposed to be, It's supposed to be in arc, but I think I didn't write it there, so I made a mistake. I was supposed to write it here. But first, let me explain how to use this very thing, this information. So a circle is divided into 2 sectors in the ratio 3 is to 7. So our ratio is 3 is to 7. But let us think, what is the sum of the ratio? Sum of the ratio is what? Sum of the ratio is 10. Sum of the ratio is 10. Now we know that sum of angle in a circle is 360. Sum of angle in a circle is what? 360. So that means that if the sum of the ratio will give us 10, so the sum of the ratio will give us 10 parts, or we could write it as 10 portions. That's the sum. This means that one portion, because the sum of the angle is 360 degrees, so 360 degrees is equal to 10 portions. So to get one portion, we divide by 10. Divide both sides by 10. So this means that 36 degrees is equal to one portion. So back to our, what's it called? Back to our expression 3 and 7. So this will become 3 portions will become 3 times 36 degrees is to 7 times 36 degrees. So this is what we have. Now ideally, there's also another way to solve this problem. You will learn that or that way very soon. So this is what we have. So 3 times 36, 3 times 36. What I'm doing is to find the angle they subtend at the center. So 3 times 36 will give 108. Then is to 7 times 36. That will give 252. Now with this, you can now see the angle they subtend at the center. You can now see the angle they subtend at the center. All right. So this information is very useful. What would I do next? I would then say the length of an arc is theta over 360 degrees times 2 pi radius. That's the length of an arc. So what is the angle? The angle is 108, then divided by 360 degrees, times 2 times 22 over 7, then times, the radius is 7. So that's our radius. So I can decide to then cancel out. So I'm just going to put all of this into the calculator. So that will be 108 divided by 360, and then times 2 times 22. Okay, so this will give 13.2 centimeter. So that's the length of the arc. Now, another way to solve this equation, if you don't want to go through the stress of finding the angle, another way to solve the equation is this. If the circle has been divided into two parts and their ratio is 3:7, you can tell that since the ratio is 3:7, this one will be the minor. This one will be the minor because 3 is smaller. So this one will be the minor. That's 3. So, I don't want to wipe. Okay. So this is the minor guy. About sum of ratio is 10. That's the sum of our ratio. Now, the minor portion, the minor arc will actually, what fraction would it be? It will be 3/10. It will be 3 over what? Over 10. That's the minor arc. So the length of the minor arc, the length will become theta over 360 degrees times 2 pi radius. But you see this value here. This value is the fraction you've just gotten. Remember I told you that this very theta over 360 tells us how many portions it takes. So this very one is the fraction. So this will become 3/10 times 2. I didn't want to clean this. Times 22/7 times 7. So 7 we cancel out 7 here. Then if you press this in your calculator, you should get the same answer. So that should give you 3 times 2 times 22. Yep, it's going to give you the same answer as 13.2 cm. So you can see that this value here is still the same answer at the end of the day. All right, so after this, we're going to move into area of sectors. So that's where we're moving up to very fast, area of sectors. All right, in this section, we're going to be talking about the perimeter. Sorry, this is area, the area of sectors. Okay, a sector is a portion of a full circle. So what is the area of a circle? Area of a circle is pi r root squared. Now what is that portion, or what is the fraction that the sector takes? The factor is calculated by theta over 360. It tells us how much we're taking from the full circle. Let me use this as an illustration. This was meant to be a full circle, but a portion was cut off. So this portion is the sector. And how do we know what fraction it took? The fraction it took will become 15 over 360. So this tells us that the length of a the area of a sector is that very fraction it takes, 360 degrees, theta over 360 times pi r root squared. That's the formula for area of a sector. So the first one, question 19, says XOY is a sector of a circle with center O of radius 3.5 cm, which subtends an angle of 144 degrees at the center. Calculate in terms of pi the area of the sector. So that's not a problem. So the angle is 144. So this is 144 divided by 360 degrees times, it says in terms of pi, so I'm going to leave pi like that. Then the radius is 3.5. So this will be 3.5 times 3.5. That's what we're going to get. And of course, I'm going to pull up a calculator so that I can easily calculate that. Remember to hit the subscribe button, like this video, and share it across to everyone on your contact list. So I'm going to do 144 times 3.5 times 3.5, then divided by 360. If you notice, I did not put pi, so you wouldn't be putting pi. Don't put pi. Don't put pi. Just do 144 times 3.5 times 3.5, then divided by 360. So this will give 4.9. So this is 4.9 pi, or the unit cm, centimeter squared. So that will be the area of that very sector. Okay, so let's move on to the next one, question 20. So these are all the solutions. So solutions started from here. So for question 20, it's a funny one, a little bit funny though. An arc of a circle of radius 6 cm is 8 cm long. Find the area of the sector. The reason I find this question a little bit easy is maybe because I've already understood arc and radii. So let's do this. Let both of us do this. It's a very simple question. See, the length of an arc is theta over 360 degrees times 2 pi radius. That's the length of an arc. This is the formula for area of a sector. They're almost similar. The theta over 360 is the same theta over 360. There's pi, there's pi. There's only one radius here, then this one has 2 radii. So what does that tell me? Is there a way I can make this area of a sector look like this one? There is a way. So watch me. The area of a sector, I'm going to first of all write this because I want to have the length of an arc, which is theta over 360 degrees times 2 pi r. Now, this we know, this is not the formula for area of a sector. We both know it's not the area, this is the formula for the area. So, what is the difference here? There's a 2 here, B, but in the original formula for area of a sector, there's no 2, right? So, what that tells me is I need to divide by 2. Because if I divide by 2, this 2 goes away. Listen, I'm trying to derive this formula, but I want to include the length of an arc so that I wouldn't solve long process. So this is what we have. Now, what else do you notice? The area of a sector has radius squared, but this one is just one radius. So what do I have to do? I'll just times by radius. And do you know that with this, I've actually gotten the formula I need to use. Let's do this. 2 we cancel 2, right? Good. So what will be remaining is what? Theta over 360 degrees times pi. Arrow times arrow is arrow squared. So what do you notice? We ended up getting the same formula back. So the formula is still the same. So what does this tell me? This tells me that, don't worry, I'm going to wipe this out. I'm going to wipe this out and I'm going to put back my 2. Hold on. So this is times 2 pi r, then times r over 2. So what do you notice? This whole formula here is length of an arc, then times r over 2. So this is another way to, this is another formula. You can use this formula, you can just maybe just know the formula instead of deriving it. So this formula stays. So what is the length of the arc? The length of the arc is 8 cm. So this will be 8 cm times, what is the radius? It says radius is what? 6 cm. So this will be 6 cm over 2. So this will be 8 cm times 6 over 2 is 3 cm. So this is 24 centimeters squared. So that's the area of the sector. No need to waste time. That's the area of the sector. Okay, so let's move on. Question 21. Question 21. The area of a sector is being given to us. So they've helped us to get the area. The radius is also given to us. But the question is, what is the angle subtended? Now we know that area is theta over 360 degrees times pi r squared. I want to do something here. I want to make theta the subject of the formula. I think it's better. Let me just make the angle subject of the formula first. Now you can tell that this is area equal theta times pi r squared is theta pi r squared, then over 360 degrees. And I need to put over 1 here and then cross multiply. 1 times this will give us the same thing, so that will be theta pi r squared. Then 8 times this will give me 360 degrees A. Now what will become our theta? We need to divide both sides by pi r squared. So this will be 360 degrees A divided by pi r squared. And with this, we can then put in everything we have. So this will be 360 degrees times the area is 246.4 divided by pi. We know pi is 22 over 7. And then our radius is 14. So this will be 14 times 14. Now you basically have to be careful in this, for this question. You have to be careful. Okay, so let me put that into the calculator. 360 times 246.4. Okay, so that's what we have. Next thing I'm going to be doing is, let me see. Okay, let me just write this answer first, so you wouldn't get it twisted. 88,704 divided by, then we have 22 times 2 times 14. So this will be 616. So I then have to divide these two together. So divided by 88,704 That's 144. So that will be the angle subtended at the center. That's the angle. That would be the angle. Okay, so that's all we have. All right, so let's continue. So question 22. Question 22. All right, for question 22, the diagram shows a circle with center O. So this is the center O. If POR is X, so angle POR is equal to POQ, equal to X. The diameter of the circle is 7. First of all, jejely, carefully, let me just go and find my radius. Radius is diameter over 2. So this is 7 over 2. That will be 3.5 centimeter. I want to carefully find that one, please. I want to find it first. The area of the shaded portion is 27.5. So this shaded portion, this is a sector. I hope you know. This is a sector. That's a sector. So the area of a sector is theta over 360 degrees times pi r squared. That's the formula for area of a sector. So the area is given to us. It says, find correct to the nearest degree the value of x. And x is an angle. X is an angle. So let's come and find theta. Remember that previously we've made theta the subject of the formula before. So let's just write that formula. Theta is 360 degrees A divided by pi r squared. So this will be 360 degrees times 27.5 divided by 22 over 7 times 3.5 times 3.5. Okay, so that's all we have. Okay. All right. So this time around, I'm going to just do everything straight. 360 times 27.5 times 7. All right. Divided by 22, divided by 3.5, divided by 3.5 again. Okay. That's a lot. Okay, so this will give us 257.14. Yep, that's what we're going to be getting. 257.14 degrees. That's what we're going to be getting. That's the angle. But this is not x. Look at the diagram. The place where x is, this place where x is. Okay, I thought I was not recording before. So this place where x is, this very place where x is the minor sector. If it's the minor sector, it has to be less than 180. The angle we just found is the angle for this other side. That's why you see that it's more than 180. So it's this other angle that we found, this other angle, that was what we found. So to get x, remember that they must be at what? They must be at a point. So that's 360 degrees. So that means x will become 360 degrees minus 257.14. So we're going to do 360 minus 257.14. So that will be 102.86. So approximately to the nearest degree, that's 103 degrees. So that's what we're going to be getting. That is what we are going to be getting. So this is the answer. This is what x is going to become. Just so you know, for angle, minor angle plus major angle is equal to 360 degrees. So it means to get one of them, all you have to do is to say 360 minus the other. That was why in this case I did 360 minus this other one to get x. So take note of that. Let's move on. So, question 23. Shown below are two sectors. The sectors have the same area. Find the length of the radius of sector B. All right, so for this question, I want to quickly check something. All right, so for this question, I want to look at this question carefully. We're told that the areas are the same. So what I will do is, this shape is complete. All parameters are intact in this very shape. So let me find the area of this very one first. So the area of that very one is theta over 360 degrees times pi r squared. So that theta is 15 degrees. divided by 360 degrees times pi. R is 20, so that's 20 squared, or 20 times 20. No need to remove the pi and put 22 over 7. There's no need. Since these two will be equal to each other, the pi will cancel out. All right, so what we're going to have next, I'm just going to do 15 times 400 divided by 360. So this will give me 5 over 3 centimeters squared. So this is the area. Let me put my pi, sorry. So that will give me 5 over 3 pi centimeters squared. So this is the area of this very sector A. Now, the area of sector B, okay, let me say area of B. Let me put it like that, area of B. So area of B, the formula is still the same. Theta over 360 degrees times pi r squared. So this will be 290 over 360 times pi times x squared. Because we don't know the radius. The radius is what? X. So the next thing is, we're going to do 290 divided by 360. That's going to be 29 over 36. All right, so this will be 29 over 36 pi x squared. Now, this is the area of the what? Of the sector B. But this area is the same as this area. So that means I can just put 5 over 3 pi here. Because the equation says they have the same area. So these two answers are equal to each other. These two answers are equal to each other. So what would I do? I can say pi will cancel out pi. Pi will cancel out pi. So what's the next thing I'm going to do? I'm looking for x. I'm looking for x. So I can cross multiply. So I'm going to say 5 times 36, then 3 will times this. So we have 3 times 29s squared equal 5 times 36. That's what we're going to be having, 5 times 36. So 3 times 29, this is 87. 87x squared. I think this should have been 270. That's I'm trying to look for where I got the equations from. This should be 270, not 290. Well, I guess I have no choice. I'll just leave it like that. Equal 5 times 36. That should be 180. 5 times 36, 180. All right, so x squared will become, divide both sides by 87. So we'll have 180 over 87. Okay, so x squared will then give us 2.07. All right, so to get s, we then need to take the square root of 2.07. So x will then become square root of 2.07. So that's 1.44 centimeters. All right, even if it's not, we didn't get a perfect answer, this is what the answer will be like, and this is how to solve an equation like this. So this is what we have. All right, so next we're going to move on to segments. That's the next thing we're going to move up to. So let's move on to segments. Let's discuss the areas and perimeters of segments. All right, so for this section, we're going to be talking about segments. Though I put in some extra. Yeah, like as you can see, this one talks about chord, this one talks about, so this is like the final part of everything. So this will be the last section for this. Then we move on to quadrilaterals. Now for question 24, before then, let me anyways, let's get started. In the diagram, O is the center of this circle and XY is a chord. If the radius is 5 cm and the length of XY is 6 centimeters, calculate correct to 2 decimal places the angle which XY subtends at the center O. Now the first thing you want to do is this. This is a chord. The formula for length of a chord, hopefully this part will be enough for me to solve all these problems. So solution, question 24. The length of a chord is 2 arrow sine theta over 2. That's the formula for length of a chord. Now the length has been given to us as 6. So 6 will equal 2 times, the radius is 5, then sine theta over 2. Now this is 6 equal to 10 sine theta over 2. The next thing we want to do is to divide both sides by 10. So this will be 6 over 10 equal to sine theta over 2. Now this can be reduced. This can be reduced, and then we're going to have 3 over 5. 3 over 5 sine theta over 2. Now, if you are to get this angle theta over 2, you need to take the sine inverse of this very side. So we're going to take the sine inverse of, if you put this in the calculator, you get 0.6. So the sine inverse of this will equal to theta over 2. So sine inverse 0.6. That will give us 36.87 equal to theta over 2. So to get theta, we need to times here by 2. Or you could say cross multiply. So theta is 2 times 36.87. So theta is equal to 2 times 36.87. That's 73.74 degrees. It says correct to 2 decimal places. All right, so that will be the answer. That is the angle subtended at the center. The next one says find the area of the shaded portion. Now that shaded portion is a segment. That shaded portion is a segment. Now I would have loved to derive the area of a segment, but I don't think we have time for that. But it's simple though. So this is the A part. The B part, area of a segment is equal to area of a sector minus area of triangle. That's the formula. So what is the area of a sector? Area of a sector is theta over 360 degrees times pi r squared. Then minus what is the area of a triangle? Half base times height. But for shapes like this, there's no base, so instead, it's half r squared sine theta. I would have as well derived this, but let me know if you want me to be deriving them. I think this is the only one that I wouldn't want to derive, but it's very simple. So this is the area of a triangle, half r squared sine theta. Then this is the area of a sector. So these two things make up the area of a segment. Now, why is it like this? Sorry, I just can't help it. I just have to do it. So this is a sector. Let me just do it. This is a sector. This is a full sector. Now, when I put a line, when I put a chord here, this portion is a segment. What does that tell you? That tells you that this full shape, which was a sector before, is actually a segment. It's a segment plus a triangle. So that means to get segment, if we take triangle to this other side, we'll then get sector minus triangle equal to segment. So that means the area of a segment is area of a sector minus area of a triangle. So I don't think I should waste for that time there. There's this guy. Okay. Okay, so let me wipe that out. So that's what we have. That is what we have. Okay. So now let's plug in everything. So we already know what the angle is. So the angle subtended by that very chord is 73.74 degrees divided by 360 degrees times pi. They didn't tell us what to use pi as, so we're going to use, I'm going to put pi like that. In your calculator, there's a part where you can put the value of pi. Yeah, so I'm just going to put it in the calculator. Then times the radius is 5. So this will be 5 squared minus 1 over 2 times 5 squared sine 73.74. All right, this will be a long one. So I'm going to put this into the calculator at once. So fraction 73.74. But I advise you, if you're a Waec student using Waec calculator, do it bit by bit. Do this part first before doing the other part. Then times 25 minus 0.5 times 25 sine 73.74. All right, so that gives me 4.08. Okay, since it's to 2 decimal places, 4.09 centimeters squared. So that will be the area. That will be the area of the shaded portion. So that's what we're going to be having. Okay, so let's move on to the next one. The next one is question 25. So I need to wipe this part since I'm using only this side. Now, question 25 is also similar. It looks a little bit similar. So the diagram shows the cross section of a run wheel tunnel. So there's a tunnel. You could travel from this point to this point, and it's a railway. So if AB is 100, so this part is 100 meters, and the radius of the arc, so that's the radius of this very circle, don't mind them, I don't know why they said radius of arc, is 56 meters. Calculate correct to the nearest meter the perimeter of the cross section. Now, this very cross section that you see, this very question is a little, I don't want to say a little bit, it's a funny one. But first things first. AB, this very AB you are seeing is a chord, hope you know. AB is a chord because the center is around somewhere here. So this is where the center is. So this is what this is, a chord. So first things first, since we have the length of the chord, let's find the angle the same way we did for question 24. The same way we did for question 24. So let's find the angle. So length of a chord is 2 arrow sine theta over 2. So the length of the chord is 100. So this is 100 equal 2 times 56 sine theta over 2. So this is 100 equal, oh gosh, I need to then use a calculator. Hold on. 56 times 2. That's 112 sine theta over 2. Then I have to divide by 112 equal to sine theta over 2. Okay, I can just reduce that at the end of the day to become 25 over 28. Let me see. 100 divided by 112. Yep. The thing is, it's not as if these things cannot be worked off by hand. I'm just trying my best to make sure that I am not wasting time and then everything is accurate. Yep. So next thing is to take the sine inverse. So take the sine inverse of 25 over 28. So that will give theta over 2. So shift sine, oh gosh. Shift sine inverse of the answer we just had. This will give 63.23 equal theta over 2. So to get the angle, we just times this guy by 2. 63.23 times 2. So that's 126.46 degrees. So this is the angle that we've gotten. This is the angle that we've gotten. But then, if you look at this shape, this part here is actually a major arc. This part you see here is actually a major arc. It's not a minor arc. Let's say that this is the center. Let's say this is the center, for example. And then I connect this to this and this to this. This angle that we have just found is here, 126.46. That's where the angle is. But we need to find this other side. You are seeing it, right? So you need to find this other angle here, because this other angle is what subtends this major arc. So you need to find this other angle. And it's very simple. To find the major angle, it's always 360 degrees minus the minor angle. So that will be 360 degrees minus 126.46. Okay, so 360 minus that very answer. So that will give 233.54 degrees. So this is what we have as the major angle. So with this, let's now find the length of the chord. Sorry, length of the arc. So length of arc is theta over 360 degrees times 2 pi r. So the angle is 233.54 divided by 360 times 2 pi times the radius is 56. Okay, I'm going to put that all into the calculator. So divided by 360 times 2 pi times 56. Okay. So that gives 228.25 meters. That's what we have. This is what we have. Now, what is the perimeter? Remember I told you that perimeter is the sum of all the length. So perimeter of that very tunnel, the perimeter, what is the tunnel made up of? The tunnel is made up of a chord. So we're going to do that very chord plus it's made up of a major arc. So that major arc. So this will become, the length of the chord is 100. The arc is 228.25. So when you add this up, you get 328.25 meters. It says correct to the nearest meter. Correct to the nearest meter is going to be 328 meters. Correct to the nearest meter. Yep, so that's what it's going to be. All right, let's move on to question number 26. All right, question 26 says, in the diagram, O is the center of the circle and PQ is the diameter. Triangle RSO is an equilateral triangle of side 4 cm. Find the area of the shaded portion. Now, this question is a nice one. The first thing I can see is that without the triangle, imagine if everything was shaded. Without the triangle, imagine if everything was shaded. What this tells me is it was a semicircle that was shaded. You see, in questions like this, you need to be able to identify the different parts of a circle and assume that if everything was shaded, what part is this? It was actually a semicircle, because they said that that PQ is what? A diameter. Is a diameter. So that means it splits it into 2 equal parts. So from this part and above is a semicircle. So first of all, let's find the area of this semicircle. Let's just assume that this triangle was not here. I want to find the area of everything. So the first thing is area of a full circle is pi r squared. But area of a semicircle will then become half of pi r squared. Why is it half? A semicircle is half a circle. It's half of a circle. So that's why. So this will be half, but we're told to use 3.142. Okay. So this will be half times pi times the radius. The radius in this case, you can see that we're not given the radius, right? But the radius is going to be 4. Why is the radius 4? If this is an equilateral triangle, it means from this point to this point is 4. And this point to this point is actually the radius. So that's 4. So that will be 4 times 4. I'm just going to use a calculator for that. Or I'm just going to use a calculator for that. So that's 16.8 pi. So 8 pi, because I want to use, before you say why am I using calculator, because I want to make sure that, yeah, so this is 25.13 centimeters squared. So that's the area of the semicircle. Now, we were assuming that this very thing you see here, there was no triangle inside. No triangle was taking up the space. So everything, imagine if everything here was shaded red. Everything here red. The area is what? 25.13. But then they put in a triangle to occupy some space. So what is the area of that triangle? So area of the triangle, what is area of a triangle? Area of a triangle in this case is half r squared sine theta. That's formula for area of a triangle. So this will be half times 4 times 4 times sine 60 degrees. How did I get 60? It's an equilateral triangle. In an equilateral triangle, all the angles are equal. So that's 60, 60, 60. That's why I did what? This thing. Right. So this will then become 8 sine 60 degrees. So that's 8 sine 60 degrees. So this will be 8 sine 60. All right. So this will be 6.93 centimeters squared. Now the question is saying, what is the area of the shaded portion? It's very simple. In this very shape, remember that I said we had a semicircle. What's that semicircle equal to? Because from this part, everything here is a semicircle. So, but this semicircle is made up of what? It's made up of a shaded region. It's made up of a shaded region and a triangle. So that means that we can take this triangle to this other side. So we then have semicircle minus triangle to give us the shaded region. Please take note, this only works for areas. So don't go and do perimeter now. Perimeter of semicircle minus perimeter of triangle equal perimeter of shaded. No, please. This only works for what? Only works for areas, because areas are talking about space. So each item you add adds to the amount of space the shape would have or must have been removed. So it works like this for only areas. So the area of the semicircle is 25.13 centimeters squared. Area of the triangle is 6.93 centimeters squared. So that will give us the shaded region. So 25.13 minus 6.93. So that will give 18.2 centimeters squared. So that's the area of the shaded region. That's good. That's the area of the shaded region. All right, let's move on. Question 27. In the diagram, XY is a chord. XY is a chord of a circle of radius 5 cm. The chord subtends an angle of 96 degrees. Okay, you can see that it's at the center. No need for them to still write at the center. There's already a diagram showing us that it's at the center. Calculate correct to three significant figures the area of the minor segment. Of course, 96 degrees is less than 180, so it's the minor segment. But if for any reason they see major segments, you need to come and subtract this from 360. But this is correct, so we're just going to use our 96. I think this space should be enough for me. So question 27. Area of a segment is theta over 360 degrees times pi r squared minus half r squared sine theta. That is the area of what? Of a segment. That's what we have. All right. So this very thing that we have, this very guy here, the angle is 96 divided by 360 times 3.142. R is 5 cm, so that's 5 squared. Minus half times 5 squared sine 96 degrees. All right, so calculator to the rescue. So we have 96 divided by 360 times 3.142 times 25. Okay, minus, let me do everything once. 0.5 times 25 sine 96. Okay, so this gives 8.52 centimeters squared. Since it says to 3SF, this is 3SF. So when you round it up, you would actually get 515. When you round this up, you then get 52. So yes, we've gotten the area of that very segment. So this is the answer. So I'm going to move to question 28. Let me wipe this side. As for question 28, in the diagram, PR is a chord of the circle with center O and radius is 30 cm. Angle POR is 120. Calculate correct to three significant figures the length of chord PR. Okay, so first things first, let's find the length of the chord. Length of a chord is 2r sine theta over 2. So this will be 2 times 30 cm times sine 120 degrees over 2. So this 2 times 30 is 60 cm times sine 60. Sine 60 is root 3 over 2. But this question was a Waec question, so I don't think we'll be using sword form. So I'll just put that into the calculator. So we have 60 sine 60. So this gives 51.96 centimeter. So that's the length of the chord. The next one, so this is the A part. The B part is length of the arc. Length of an arc is theta over 360 degrees times 2 pi radius. So theta, which is the angle, is 120 degrees divided by 360 degrees times 2 times 3.142 times 30 centimeter. All right, though this will give you 1/3 when you cancel out. But okay, so that's 1/3 times 2 times 3.142 times 30. So this will give 62.84 centimeters. So that's the length of the arc. So this one is for arc. C says perimeter of the shaded portion. Haha. Perimeter. It does not say area. Perimeter. This is where it gets interesting. This shaded region first is a segment. The perimeter of a segment, remember I told you that perimeter is the sum of the length of the outline, or perimeter is the outline of a shape. So what is the length of the outline? First, what makes up a segment? First of all, we're going to have a chord. So this is one of the lengths. In fact, let me just kind of replicate this. So we have something like this. So this is what we have here. So this is an arc. This curve is an arc. So it's always the length of an arc plus the length of a chord. So take note. Perimeter is the sum of the sides making up a shape. So this very sector is made up of a curved arc and a chord. So the perimeter is always length of an arc plus length of a chord. So the arc we have solved for it, as 51.96 centimeter. The length of the chord is 62.84. Sorry, I even mixed it up. Anyways, length of the chord, this is the length of the chord. I mixed it up, but it will still be the same thing. It will still be the same thing when you add up. All right. We're going to add 51.96. So that's 104.8. It says to 3 significant figures. So this will become, oh, even this one, they are all to 3 significant. Oh gosh, I didn't pay attention to that. To 3 SF, this will be 52.0 centimeters. Because if I need 3 SF, that means 3 numbers, 1, 2, 3. But this 9, the number following the 9 is 6, which is a round up. So I'm going to call that 1. But when I call it 1, this then becomes 52. Now over here, this will become 62.9. Oh, this will become 62.9. Sorry, 62.8. Because I need to see where again. This 4 is a round down. So since it's a round down, it's going to just be called 0. So this will be 62.8 centimeter. All right, so I'm going to make that change. So this will be 52.0. Then this will be 62.8. All right, and I think the highest that will be is 11. Let's see. 52 plus 62.8. All right, so this will give 114.8. But then, if you need just 3 significant figures, this will be 115 centimeter. That's what we're going to be getting for that. Okay, so that's what we have. Okay, so let's move on to the last question. Question 29. Find the area of the shaded region. Just before I do that, in case you need the perimeter of a segment as a formula, the perimeter of a segment as a formula is theta over 360 times 2 pi r plus half r squared, I said half, sorry, plus 2 r sine theta over 2. So this is the length of the arc, this is the length of the chord. So in case you need it as a formula, this is the formula for perimeter of a segment. All right, question 29. Find the area of the shaded region. That's this blue portion here. Now, the thing is this. This shape has a name. Some people call it the annulus, while some people call it a ring. So there's a formula for this. But I think it makes sense to just kind of write it out. The formula for this is pi bracket r squared, that's the external radius or the bigger radius, minus small r squared. That's the formula for the area of the shaded region. But why is it like this? It's like this because let's say we want to find the area of the big portion. So area of the big one, that will be pi r squared. So that will be pi times, what's the big radius here? 11. So that's 11 squared. So that will be 121 pi centimeter squared. So this is the area of the big circle. How about the area of the small circle? The area of the small circle is still pi r squared, but we're going to be using the smaller radius. So that's times 9 squared. So that's 81 pi centimeter squared. So this is what we have. The shaded region you can see that it's in between the big circle and the small one. So here's it. The big circle has this area. Then another circle is occupying some space. What this means is, if you can remove this small circle, you can be able to find the area of this shape here. So that means the area of the shaded region, is going to become 121 pi minus 81 pi. This should be 40. It has to be 40. So that's 121 minus 81. So this will be 40 pi centimeters squared. You can put your pi as 3.142 is your choice. So this is what the area of this very section would be. Remember to hit the subscribe button, like this video. More are going to be coming up so that we make sure that you pass your exams very well and move into the university. So let's proceed. I'll see you in the next video.